Today's episode, we're going to be syncing up player positions and also player input. This will be one way of going about doing it. It won't be necessarily the absolute best way, but it will be functional, and you can consider how to optimize it in your own endeavors. Now, this isn't going to be syncing up entity, as you can see kind of how the ball position isn't synced up. We'll be doing that in the next episode, but player input, however, is being replicated and shared across, along with exact XY position for the most part. You can kind of see how it is pretty spot on, syncing up between lights. And this is over the Steam networking interface. This is not local area network. This is using Steam players connecting from one person to another person. So let's get into that. So before we get into this, I want to kind of explain the logic we're going to be working through. There are many ways to kind of organize your logic for multiplayer interaction, but the way we're going to be doing it is kind of something I learned from Unreal Engine's documentation, is the way that the client never really has the authority to do things by itself. It has to request. So the host is what's going to be actually kind of telling every client that they can perform certain actions and authenticating it, because the host should be the one that is authenticating every action, every bullet, every jump, movement, collision, things of that nature, so that there is a similar experience on every other platform, because it's running off of one source of truth. So for example, if the client wants to move, client will send the request to Steam, and then Steam will then send that request to the host. The host will then, determine, okay, yes, this player can move in X or Y direction, so that'll tell that to Steam, and then Steam will then respond back to the client, showing that movement. Now, while that's all happening, what we're going to also do is have periodically the host environment, the server, will be telling Steam the position of all the players, updating every single client the position of everybody, so that everyone's kind of all synced up with their positions. They're also going to be receiving whether or not, if this client is moving, pressing spacebar or pressing the up arrow key or down arrow key. As they're requesting that access to do that, the server is also telling everybody else, hey, by the way, through Steam, let me clear up all the arrows. The server is also telling everybody else through Steam, hey, by the way, this player is moving around. So make sure that you recognize in your game client that they're also moving. Now, this is mostly just, you really don't have to replicate every single action. We really only want to replicate their inputs. As far as gameplay results, like if a user dies, or there's an animation that's being played, or graphically something's being displayed on the screen, that's done on the client itself. But as far as user position and the actions they're performing, whenever they start, or whenever they're being triggered, that should be authenticated by the host at some point. Otherwise, you can have clients that will say, hey, I'm shooting a gun and I'm shooting this client. If the server doesn't really authenticate that or allow that to happen, you can cheat, right? So we don't want cheating to be occurring. We want every action to be authenticated by the actual host itself. So let's try to get that written out. Continuing from where we left off last time, we're going to be touching a few objects that we have in play. We'll be editing a few scripts, but we're mostly going to be tinkering with the client, the server, and the player. These three things. Everything else is kind of already in a good position, but let's start with the server. In the server, we so far have this create to kind of initialize a few variables, and some script that runs on the room start to spawn all the players. That's fine. But we need to add something new here, because the server is now going to be receiving packets. And so just as we did with the client, we need to have some kind of template buffer for things to be loaded into. So similarly to how we did on the client, we're going to be describing a variable called inbuff, and we're just going to do a buffer create. We'll have it start out as 16. We're going to label it as a buffer grow, because we're going to be using this periodically, and we want it to grow to its size, whether it's 16 or larger, it doesn't really matter. This is just to initialize it as a buffer so that we can use it later on. And we are actually finished here. The next thing we're going to be doing is in our begin step, because before we have animations and just collisions and happening in the step of the game phase, we want to receive all of our packets starting out. description, listening for activity as server. And here we'll be receiving packets. So the way Steam does this, as we did in the client section, is while Steam net packet receive, do the following, right? This is essentially copying everything we did from the client, which we can just open up the client and copy what we do here. This is the exact same stuff. This is how Steam is going to be, we get who's sending the packet that's coming in. We get the data from the buffer. We shove it into this buffer variable that we defined here. So it's an existing buffer that's already there. It starts at the very beginning of the buffer, and we want to read what type of buffer is this, because remember, we're using our kind of our macros here, right? Our packets, so that we can determine what logic we need to apply to the packet that we're receiving, and we can determine what we're going to be doing. And so let's start out with that. And then whenever we receive the packet, and we are now trying to make a switch statement to what we're going to do with the packet, depending on what it is, we need to kind of switch on the type. And this is where we need to define a new network packet. So we're going to add a few in here. We're adding 3 new ones. We're going to do client, do all caps, client player input. We're just going to have that equal 10. Server player input. Ooh, spelled that wrong. That equal 11, and then player position. That equal 12. So let's go ahead and get that written out. So the only thing we're doing from the server's point of view is receiving player input. And from there on, we need to do things with that. So in the case that we're receiving a network packet client player input, we want to do the following. And we're going to work this out a certain way. We're going to try to clean it up, because before we were doing all the logic in the actual begin step. We're going to do it a different way and put the logic inside of an actual script so it's cleaner. So player input, we're going to receive player input, and we're going to send a buffer to that and send who's actually sending it to. So we need to create a function called receive player input, and it's going to receive the buffer that we've gotten, and it's also going to receive the Steam ID, the player that's actually sending over the input. Once we receive the input, we need to then send that input to all of the other players. So all of the clients will be aware of what buttons the other clients are playing to. And all of this is being authenticated or validated by the server itself, by the host. So player input to clients, player input. So these 2 functions we don't have just yet. We're going to put them in. We're just getting this switch case set up. And then once we finish doing that, we're finishing the case. That's it. If for some reason we do end up getting an unknown packet sent to the server, we just want to kind of put a debug message. Unknown packet received. String type. Break. Now this is just in case for some reason we mess up and we send the wrong packet over. Because remember, this client player input, this packet value is equal to 10. But if for some reason we're receiving this packet there, this will print out a message. It'll say unknown packet received 11, because that's the value of that. This is just more for debugging in the event it occurs. Shouldn't ever happen though, because since we have this break statement and we receive this packet, it'll just perform these 2 actions and then stop, and that's it. So we're actually good here. The server is in a good position. Now let's go ahead and define these 2 functions. We need to create receive player input and send player input to client. Let's go over to our player management script. Now it doesn't really matter where we're putting it, obviously, but just for my purposes, we're going to put it here. Let's move this up here. Now this function we're going to be creating is going to be described description as player input packet reading for server and client scenarios, right? So this will be ran by either the client or the server object, because we're going to try to make this multi-use. So you receive player input, and remember we're wanting to receive the buffer and also the Steam ID of what we're dealing with. Now to make this multi-purpose for use in our future tutorials, we're going to make this equal to -1. Before we start receiving the buffer, though, we probably need to also define how it's going to be sent, because we need to understand how to read what's being written. So let's do the writing part of this function first, which would be the opposite end, where the client is sending player input. So this is something that would be ran specifically by the client object. And this function is going to be called send player input. And it's just going to take the input, and it'll also take kind of who we're sending it to, the lobby host. We don't want to be sending player input to other clients and stuff, because we need the host to actually validate all of this actions and then send that input back to the other clients. So in the input, we're going to be kind of sending all of our keys over whenever we perform an action, and we're going to kind of put all of this in variables and then create a buffer for it to go into. Now, when the client sends this over, we need to create the buffer, and all of this input is really just zeros and ones, right? The right key, if you're pressing it down, it's a 1. If you're not pressing it down, it's a 0. And so everything really is just the tiniest of values. So we have the first packet to determine, hey, we're sending client player input to the server. The xInput is just going to be a signed value. The yInput is also just going to be a signed value, because it could be -1 or 1, depending on what key is being pressed. And our action key and run keys don't have to be signed at all, because it's just whether it's being pressed or not being pressed. It's 1 or 0. And then we are sending it to the lobby host. This is a whole buffer. Once it's sent, we then delete the buffer so as not to have a memory leak. We also need to make sure that we clean up the buffers. So this function is finished. We're good there. So now we need to write out how we're going to receive it. For sake of speed, I'm just going to kind of copy and paste it all here. And let's go through each one. So starting off, if we did not receive a Steam ID whenever we called the function, we're just going to go ahead and make sure that we read the Steam ID in the original buffer. This will be more for a client scenario. Whenever we're sending it from the server to the client, we will be sending them the Steam ID. However, when we're receiving it as the server from the client, we'll already know what the Steam ID is, so that's what that conditional is for. Then we have the xInput and the yInput, having it match the signed buffers up here, same thing. The run key, the action key, any other keys that you have assigned. And then this player, we need to determine what player in our game does this all associate with, because we know what the Steam ID is, so now we need to match it up with the actual player. So we need to make a function. Called firePlayer by Steam ID, and we'll figure that out. And if for some reason that function doesn't actually find a player associated with the Steam ID, maybe let's say, for example, they haven't spawned just yet, so the input doesn't need to be registered. It doesn't really matter, so we'll just have the function return and fail out. But if it did find the player, well, then we need to set the player's xInput and yInput to whatever we got from the buffer, whether or not they're pressing the run key or the action key, and then we're going to return it to be able to send it to all the other clients. And we're going to be using that in our other functions as well. So that's how this works. Let's go ahead and write up this function right here, find player by Steam ID. This will be a fairly simple function. Once again, this is a function that's going to be used by both the client and the server, because we're going to be using it frequently. And so we'll just say that finding player object on client server. So function find player by Steam ID. It's going to take a Steam ID as a variable. And so what we're doing here is we're just going through the array of the player list. Because if we remember, on our server object, when we create it, we have this player list that's created, and every time somebody joins in, we have it, push the new player and all of their attributes and everything into this player list, this array, this structure that we created to begin with. So what we're doing here, let's zoom in again, is we are just iterating through the entire array, and we are checking through every player list, if the character exists, the player object character exists, and if the Steam ID matches the Steam ID that we just gave it, well then okay, then we're just going to return that character. That way we can say that character's xInput and the yInput, and the run key, what it's all doing, so that the game knows what to process for that character. So we're going to use that function just to be able to get that. And it returns the player if it finds it. Otherwise, it returns no one, wherein the function will fail in itself, and we won't have any errors there. So cool. We have those two functions in place. Now we have a way to send the player input. That function exists. We have a way to receive the player input. Now we need a way to send it to all the other clients, because this is the client sending of input, right? We don't have the server sending of other players' input to the lobby, if you will. So let's do one more function. We're going to put this in lobby management of this server. I'm actually going to drag this up here, put it in there. There we go. Now our lobby management, we already have a few things here, like send player sync, send player spawn, send other players spawn. There was one thing I needed to fix though. This wasn't performing as I was wanting it to, this shrink player list. This was kind of doing some weird stuff. So let's go ahead and actually kind of comment all of this out. I'm going to Control K there, and we're just going to return the player list itself. I was thinking there's a way that I was trying to reduce the, what do you call it? The amount of time it was between it syncing up and spawning everybody, but I couldn't get it just right. There's something else that's there. I think it's waiting for the server to actually join. But anyway, this actually doesn't take that long in comparison. I was doing the wrong thing. So just replace that with that, and we're gonna not run into issues later on. So we already have some other player spawn. All these other functions are fine, but we're gonna make a new one now. And this is going to be ran by the server. So we're also going to do self obj server. Let's bring it up here. Send player input to clients. And it's going to take the player input, and it's going to do a bunch of process with it. Now this function, if you remember, is what we determined over here, to where if we receive the player input, which this should, now that the function exists, it should light up. Let me delete something. Did I word it incorrectly? Receive player input. Oh, I did the IE mix up, that's why. Anyway, I before E except after C. Yeah, that's right, okay. And so we're receiving the player input, and then we send the player input to the other clients. So this is the next function we have here in our lobby management section. And let's go ahead and set this up. Now, this one is very similar process. I'm going to go ahead and just copy and paste everything here and talk you through it. So what we have here is we are just doing a validation thing to avoid any errors. If for some reason the player input we received, let's say it didn't find a player, that means that in this variable, if this function failed to find an associated player to the Steam ID, it was going to return nothing, right? It was just going to fail out. So if for some reason it's nothing, we don't want it. We don't want this function to fail. So the decision I made here was just to put that logic in the actual function. So if it's undefined, just return it. But if not, continue on. So we're creating a buffer, and this time we're actually sending a Steam ID along with all of the input. So we need to have a U64, this larger buffer packet, to contain the Steam ID of the player. Now there are probably more efficient ways you could do this. You could probably only send the last half of this Steam ID, and that would reduce this from a 64 to a 32, and that would only be 4 bytes, because the way we're doing this, we're going to be sending this a lot, and that could be a lot of unnecessary packets for unnecessary latency that could occur. In our test here, we won't really see the effects of it, but let's say you have a larger lobby, 16, 30 players, something like that. You need to really optimize what packets are you sending all of the time. But for this scenario, it'll work just fine. So we're sending the Steam ID, and then we're sending the input, all this stuff, all of the things that we determined that were being returned here, right? All the Steam ID, xInput, run key, action key, all of those things that were received in the original buffer that was sent by the client, we are then sending as the server to all of the clients in the lobby. So we're creating the buffer, And then now we need to iterate over our player list as the server. And for every player that is not us, so we're doing a little check here, if this particular player in the player list has the same Steam ID as the server, we are not going to do anything. We're just going to not send that packet. We don't need to send ourselves as the host what the other clients are doing. We already received it. We already know what's going on. So it's an unnecessary step. So if the player is not us, go ahead and send this packet that we just created, this buffer we just created, to them. And then they need to receive it. And remember, we're doing the server player input identifier on this packet. So now that we've sent that buffer to every single client, we now, I believe all of our logic on the server end of things is good. As the server, we are now receiving the player input, and we are now sending the player input. So those are two big steps. So now we need to kind of hop over to our client section. So on the client, we already have a few packets that are being, taken care of. But what we need to take care of now is this new packet we described, which is a new case. Let's put a few lines here. And this case is called network packets server player input. This is whenever we're receiving something from the server. And what we want to do with it is just kind of unpack that buffer and get all the input and apply it to the correct person. Now we have a function that already does this that we defined earlier, and it was receive player input, right? And the buffer that we got is this inbuff. And once we finish doing that, that's all we want to do. We just want it to perform the action, receive the input, and apply it to the proper player in the game. And just for reiteration purposes, we have over here the function that we defined earlier, receive player input. And since we're only sending the buffer, we're not sending the Steam ID, is going to attempt to get that Steam ID first and then get everything else. So we already did all the logic earlier. We're just kind of putting it in the client now. So luckily this function will work for both the client and the server. Now that we receive the player input, it'll update the position. Oh, it won't update the position. It'll update their key presses here. We're receiving their input, remember. We're not really updating their position. Now the game will have its logic and kind of try to move them around. And we're going to see the effects of that before we send over the position, just to explain kind of what's going on. Oh, I forgot one more thing. Since we are determining our input based off of pre-calculated xInput and yInput and things like that, we need to actually change how the player works. I forgot I changed that. So normally our step, the paddle movement, is based off of X is the function, the result of right key and left key. For simplicity, we actually we wanted to condense the packet down to just a single variable, either -1, 0, or 1. And so we did this calculation already before sending the packet over. So we're actually going to replace this logic in our player movement script. We're going to replace that with xInput and replace this with yInput. And we also need to make sure that those variables exist on the player itself, because remember, this function is being called on the player object. So in our create step, we need to also add xInput equals 0 and yInput equals 0. Just so that those variables exist already. So as they're being called, it doesn't fail saying, hey, this doesn't exist. You can also put this inside the init controls if we wanted to, and just put it over here. Oh, actually, let's put it up here. And we can just indent it so it looks all pretty and nice. That way, these variables will exist. So 2 changes. We added it to init controls, and we switched our player movement to take into consideration xInput and yInput variables. I also forgot we need to change a little bit of the logic on how the player object determines whether or not it is the local player and whether or not it is also the host, because we are wanting to send over player movement from the host to the clients, but we also want the same object to be able to be controlled by the host itself, and each one needs to be able to determine if it's local. So we're going to also have a variable called lobby host, and we're going to have that equal to Steam lobby get owner ID. And we also want to determine whether or not this player is the host. Steam lobby is owner. And those two functions should let us know kind of what we need to know. Now that we have those two things set up, we can now alter our step-by-step scenario. And when we get controls, we need to actually modify this. We need to not only send whether or not it is the host or if it's local, we also need to send over, is it the host or is it not? So we need to modify, I middle click there, we need to modify this get controls thing. So we're also going to say is host, and we'll also just let's call this is local, just so it matches up what we're sending it. So we're going to switch this up. We're going to be if it is local and it is the host, so that we're going to put two statements here. If is host and is local, we'll then do the following. And we're actually going to not only do this, but we're also going to, since we switched how player input is being applied to movement, we need to do that calculation here. So we need to also make sure that we are doing xInput equals the right key down key, or right key minus left key, and yInput equals down key minus up key. And now that we have that in place, we are almost done here. Whenever the host performs an action, we also need the host to send over its input, right? So we need to send host input to clients. And this is only running if it's the host and it's the local player object. Like it's my player character that I'm controlling. So we need to create an input variable. And we're essentially copying what we did in that previous function where we were creating this whole thing, but we're going to create it with our stuff. So we can copy that if you want to. Paste it here. And we're replacing all this underscore stuff with just what we have up here. So our Steam ID, well, it's our Steam ID, which is just that. Our xInput is the same thing there. All of this just doesn't have the underscores because we're not creating temporary versions of it. It's just directly copying all that down here. And we need to send player input to clients. There we go. And it's just this input because we're sending our own input to all of the clients. So we already have that function that exists and we're good. Now that is for the host. We need to create another statement if it is not the host, but is also a local player. And this will look very similar to what we have up here, but slightly different because we don't want the player to be able to directly affect its movement. It needs to request that kind of movement. So I'm going to copy all these variables here and explain what's going on. So you'll see that I'm creating just kind of temporary variable references to our keyboard and controller presses. I'm not including these clamps. The clamps really are kind of unnecessary. Somebody said it was good practice, but I don't know. It's not terribly necessary. Then we have the action inputs, and we're sending these inputs in the same way. We're saying the right key is our right key variable up there. Our left key is our left key variable, down key, blah, blah, blah. And we're sending that player input to the lobby host. Remember, we decided to, when the player is created, player object is created, we have this lobby host that's gathered right there. So now that we're doing it here, we're able to send our player input to the lobby host, and then the lobby host we'll be able to, send it to all of the other clients so that we're good there. One other quick thing that I messed up, apparently it was a bug from a previous one, on the object client, make sure this instances does not say instances1 when you're spawning another character. It needs to be instances, otherwise it's going to mess up. So yeah, quick note, instances, because it needs to match that layer or else it won't be able to create the player object, and it's all going to mess up all the logic everywhere else. So make sure that matches at least when we do that. And with that, I think we're finally ready to test. I keep forgetting step by step each thing. So with just doing those things, we now have a sending and reception of player inputs. Let's go ahead and see what it looks like whenever we're not syncing up X and Y positions. We're merely sending over input with whatever latency Steam is going to introduce. Okay, so we can finally test this. Host the first lobby, join the lobby on computer number 2, and the computer number 3, we're going to join, and we should finally see all players once it's all synced up with everyone. And we have the host is playing, we have one of the clients are playing, and one of the other clients are playing. Now when I press the button, we can see it match up. Now you're noticing the X and Y positions aren't really matching up. There's a slight desync, even though I'm having proper input, whatever latency or whatever it doesn't detect me sending an input just exactly, there's a little bit of desync as far as where everyone thinks their position is, because I'm sending over the input, but I'm not syncing over their position. A good practice is to constantly be syncing over their X and Y position whenever you have the ability to move so much. Whenever you're just doing like a turn-based kind of game, like let's say you're playing something like chess or whatever, and you're just sending over the input at one at a time, you're not really matching up exact number for number X and Y positions. You're just kind of matching up, oh, they pressed a button there, they pressed this button, that just so you know. So when we're doing this, in order for things to match up just exactly the positions on every single person, we should periodically also update their X and Y positions. Now those are small packets, so we can send them, very frequently all the time. But we need to make sure to do that. And it's actually pretty simple to integrate. So as we did before, we're going to start with the server again. Now, the server will never be wanting to receive a packet of updating the player position because the server is determining where they're at. The server is the one that's allowing them to even, send input and press jump or go left or go right. So the server, what it really needs to do is just have something that it's doing, kind of like on an automatic basis. It's just always doing it every so often, and however many times per period you want to do it. And we're actually going to do this with an alarm. So we're going to set up an alarm. And this alarm, we're just going to be syncing the player position, right? That's the only purpose for this alarm. And we're going to create a function that's going to be called send player positions. And its sole purpose is just to send it to all the other people. And we want to trigger this alarm every so often. So the way you do that, and some kind of trick notation, is you just set the alarm, whatever, integer value is. This is the first alarm, so it's 0, equal to 5. So in the next 5 ticks, it'll then run the same alarm again. And whenever we start the room, we want this alarm to also just, start up. Anytime we have a new room start, a new level that starts up, we want this alarm to be triggered. We want this syncing of player positions to happen every 5 ticks, just all the time. Sync up the X and Y positions of all the players. That way, we're kind of more or less synced up. And let's go ahead and define this function. And this is kind of managing the lobby. So let's just go ahead and put it in the lobby management under the server. Let's go all the way down, pin it to the bottom, and I'm just going to copy this over. We are going to essentially only run this as the server object. So we're going to put the self to there. And we are going to, I think I had to put 3 slashes. There we go. Oh, yeah, I've been doing 3 slashes. And the purpose of this is just, let's also do a description. Why not? Description, constantly update other clients on every player's position. So what we're doing is we're iterating over the player list, and for every player that's there, if it has a character, then we're going to perform the action. There are sometimes, like for a few frames, when a player connects, their character hasn't necessarily spawned. Their Steam ID hasn't been assigned to the player just yet. So what we're wanting to prevent is, for those few frames that doesn't exist, just skip over those players. Don't worry about them because they don't have a character yet. I don't have to sync up their X and Y positions. So we're just, as we're looping through this, if it detects anything is undefined, just continue. So skip everything else. But if it does find that the player and the character and they have a Steam ID, everything associated, we're going to create a buffer. We're going to first say this is the player position packet. We're identifying the buffer with that logic. We're then sending over the Steam ID of the character. We're sending over the character's X position, Y position, and we're creating the packet with that, the buffer with those packets. And then we now need to send that to every other player in the server. So we're iterating again over the player list. And as long as the player in the player list is not our own player, or not ourselves, we're going to skip it and send that information to all of those other people. So what this function will do is it's going to create a buffer for every player that contains that player's X and Y position, send that to all of the other players in the lobby, including themselves, because we want to make sure that the client who's playing sees themselves as the server sees them as well, where they're located, so that when they collide with an object, when they get hit with the bullet, when they run into an enemy, the server and the player see the same thing. So we're wanting to sync this up all the time. And then delete the buffer and create a new one for the next player. So this will create kind of like the loop that needs to occur throughout the whole time. And that is happening every 5 ticks, which you can turn it up, turn it down, however you want to do it. It really just depends on the kind of performance you want to get. If you're having this run so fast, like every single frame, it can get intensive. I don't know if you noticed, but the player input that we're sending every single frame, and that might be a lot of unnecessary packets being sent. That kind of optimization, I'm not the best go-to with it, but I just know that this does work. It might not be the most efficient, but it does get the functionality there for testing. So the server is sending that information. Now we need to have the actual player know what to do with that information. So we need to write another function for the player, and we'll plug it in later. But essentially, it's just logic so that the player knows how to update other players' positions. So we need to, when we receive a buffer as the client, we need to update whoever position this is on our local, our local player list that we have as a client. So as we saw earlier, we are sending over the Steam ID and then the X and the Y position. So with this function update player position, we're taking the buffer as a variable. We are, why is this? Oh, okay. That's wondering why it was mad at me. So we are receiving the Steam ID, X position, Y position, and then we're iterating over our local player list that we have here as a client. And if the Steam ID that we got in the buffer matches the Steam ID of a player in our player list, then go ahead and do the logic, apply the information. However, if that player in those few frames where if we're a client and somebody joins in, or if their character's dead, or if they haven't spawned, then don't bother setting their X and Y position. But if they do have a character, attempt to sync up the X and Y position with the X and Y position that we got in the buffer from the server. So that is running. Now, as a client, we now need to set up one last spot. So the last thing for the script is, if it's receiving this network packets client, player position, we want it to update player position with this buffer that we just received and break. That's it. We define the function elsewhere. It's so much cleaner to do it this way versus having it all like this. I really need to refactor all of that, but it's good to see both ways to see how you can set it up yourself. So with those things in place, we should not see that inconsistency with everyone kind of, not lining up in their positions. So let's try it now. All right, so let's go ahead and host the lobby. And I misspelled positions. I spelled it potions. Well, don't do that. There we go. Try it again. Okay, host in the lobby. There we go. Join. And let that sync up. And join on the other guy. And here we go. All right, so now if I move crazily, you'll notice that it pretty much matches up exactly with all the players. No matter how much I do, or if I shoot and I move slowly or whatever, it is all the same. Our X and Y positions are all synced up and nigh perfect. And we can actually, oh, that's coincidental. The ball isn't synced up at all. It just happened to be somewhat lined up there. But our player positions and our player inputs and actions are all synced up and match no matter who we are. And that's all over Steam networking. That's not using local network connections or anything. And it works. One cool thing this can also fix, I don't know if you saw earlier, but if I start the game and I'm in a different position and I join in, the players that join will see the new position that the other player's in, because the positions are all synced up. They'll spawn in the right spot because we're constantly syncing over the position every 5 ticks. But yeah, so you can actually now somewhat play a game with each other. Now you gotta do more logic, right? You gotta sync over all the entities and the enemies, and if you're hitting a switch, if a door's open, things like that, you can sync over those kind of actions. And all of that, as you're syncing over player input, a lot of it is really just the game will control it. If the player's in front of a door and the player chooses to press the interact button, it'll send that input to the server, and the server will send it back to everybody else. Yes, he pressed this button, and then the door will open or whatever. There's a lot of ways you can already kind of have a functional multiplayer game with just this setup alone. But next episode, we'll deal with entity replication and trying to deal with syncing up enemy positions and enemy actions so that everyone can see it the same way. But yeah, hope you enjoyed this. Hope this was helpful. I know it was also lengthy, just like the last one, but there's some good meat on these bones.